Today we're going to take reflections and rotations, and we're going to use our tools, and we're going to do advanced reflections and rotations. So you want to make sure you have this page out in front of you, and you want to make sure that it's on the side that says reflections. We're going to reflect first. It's not complicated, but it is multi-stepped. And so when we do one of these reflections, I want you underneath to summarize, like, what did I do? Because I don't want you to get home and then look at all these markings and not remember what we did first and what our process was. Let's look at our first example. In our first example, the line of reflection is already going to be drawn for us. We are going to rediscover what we discovered yesterday on the laptops about how the line of reflection is related to the segments we draw when we connect the vertices of our pre-image and our image. So, I want you to go to that first shape right there. The only thing you need so far is a ruler. I want you to connect the corresponding vertices. Go. Once you have connected the corresponding vertices, I want you to confirm with your tools that line M is what you think it is. What do you think line M is? What do you think it does to those segments? Excellent. Yes, it's going to do what you think it does. Line M is going to be the perpendicular bisector of the segments that connect the corresponding vertices. So let's confirm that with our tools. Let's remind you how to use a protractor. Yours probably does not look like the same as mine because these are just old ones from our math cabinet, but to confirm that it's a perpendicular bisector, you want to make sure that those are 90-degree angles. So you line your protractor up with one of those segments. You put the center of your protractor at the vertex, and then you check out how many degrees we're looking at. If you see right, oh, it's auto-focusing, you can do it. You see right there, it does say 90 degrees. So that right there I just measured is for sure a 90-degree angle. Now the other part of that word is bisect, perpendicular bisector. How could we confirm that it's a bisector? Ruler, yep. You could measure E prime and make sure that it goes through the midpoint. So I'm getting 5.5 centimeters. So we would want it to go through 2.75. Boom, totally does. Tick mark, tick mark. So underneath your picture, I want you to write a sentence. Do you mind if I put LOR? It's not Lord of the Rings. Line of reflection. The line of reflection is the perpendicular bisector of the segments I'm just going to do connecting the images, and we'll know that it's connecting the corresponding points on the images. We don't want our sentence to have too many words and confuse ourselves. Okay, so let's go over those steps again. I want to make sure we know what we did. We connected the corresponding points on the pre-image and the image. We measured the angles formed, and we got, of course, 90, 90, 90 all around. We measured the length of each segment and confirmed that it was congruent on either side of the line of reflection. That's also confirming that they are equidistant. And then we wrote a sentence. Our sentence looked a little bit like this. The line of reflection is the perpendicular bisector of each segment joining each point in its image. Okay. Ooh, now you have two triangles and there is no line of reflection. So I want you to use what you learned yesterday and what you know about lines of reflections and draw your own perfect line of reflection. Go. Okay, so as you can imagine, step one would be to connect the vertices that are corresponding. So you're doing it with a straight edge, even though Ms. Tanton is doing it by hand on the smartboard. Okay. Once you connect the corresponding vertices, you have choices. You have options. Give me an option. What's one thing you could do? Hatham said midpoint. So you can take your ruler and you can measure the segment and you can find the middle of how many? How many segments would you need to do? No? Yeah. How many points define a line? It takes two. Remember I played that corny song, It Takes Two? So yeah, you could measure with your ruler. You could locate the midpoint with your ruler. You would have to locate two midpoints. One wouldn't do it. And then you can, of course, connect those with a line without measuring the other one. So that is one way to do it. Let's write it down. Two midpoints. Another way to do it that Jesselyn did was you can draw one segment, connect one point and its image, and you can construct the perpendicular bisector of that one segment. So no need to draw any others in. I only have to draw one segment, one perpendicular bisector. Once you draw it, it's drawn. You don't need any other information. And that is my line of reflection right there. So that's another way to do it. Construct a perpendicular bisector. Only one of them. Another way to do it that you guys mentioned was, I bet some of you found the midpoint, and then with your protractor, you measured a 90-degree angle. That one might not be quite as precise, but if you're good at measuring and you're putting that one right at the midpoint and making your tick mark, then that should be fine. You should be able to do that. Just make sure you're connecting two dots to each other when you do that. Let's move on. This next one's called coordinate geometry. I only want you on this one. Here you go, Hatham. I only want you to use your straight edge here. I don't want you to use a compass or a protractor or the markings on your ruler. I want you to know, because it's on a grid, I want you to use what you know about coordinate geometry to draw the line of reflection. Go ahead and name it in. Go. So we know good old step one is, of course, to connect our corresponding vertices. Notice I only connected two of mine, and I tried to pick the least complicated one. Y passes over the figure, so I chose not to connect those. I only needed two of them. Now, on the other examples, we located the midpoint using a ruler or a compass. But on this one, I want you to use what you know about the coordinates. I want you to locate a midpoint using your grid. Now, of course, you could find those coordinates and you could use the midpoint formula, but that's going to take you a while. You can always count from x prime to x, count your rise and your run, and then just go half of your rise and half of your run. Yes, counting is allowed and acceptable. 1, 2, 3, 4, 5, 6. So now I only have to go half of that. 1, 2, 3, and then I just go over till I meet my line. That is my midpoint. Z is a little bit easier. Rise 2, run 2. So I'm going to rise 1 and run 1. When I have two confirmed midpoints, I am done. I just have to connect them, and I have my for sure line of reflection. No guessing here. I think it said name it M or N, whatever it said. Let's write the equation of that line. What is the equation of our line of reflection? Y equals mx plus b. Awesome, Toby. Toby has Euclid label back. So yeah, our answer is y equals mx plus b. Well, it goes through 0, 0. So there's no y-intercept. So the equation of our line of reflection is y equals negative x. Okay, I want you to go ahead and do the same thing on this one right here. Draw your line of reflection and write the equation. Go. So of course our first step is to connect the corresponding vertices. Oh good, Hatham. I try to choose the least complicated ones, the ones where I'm crossing over the least amount of lines to get to the other point. So I chose B and C. We're going to do just like we did in the last problem and locate the midpoint. Rise 1, 2, 3, 4, run 2. So go half. Rise 2, run 1. Rise 1, 2, 3, 4, and run 2. Same thing. Rise 2 and run 1. So we located our midpoints, and then we connect the dots. And then Miss Tanton wanted you to write the equation of the line. Oh, you already got it. Okay. I didn't even ask, you're right. Y equals 1/2 x plus 4. So 4 is our y-intercept. Our slope is rise 1, run 2. Cool. So y equals 1/2 x plus 4. Now, I want you to stop real quick and tell me what the slope of B prime is. What is the slope of segment B prime? Okay, good job. So the slope of that line is -2. What is the relationship between this number and this number? Fancy word? That's the next question, Sharon. Not just that word, Toby. Okay, you're not saying it. They are opposite reciprocals. We learned last semester that if two lines' slopes are opposite reciprocals, then they are perpendicular. We know they're perpendicular because the line of reflection is the perpendicular bisector, blah, blah, blah. Okay, so we're going to use that knowledge on our next example. Go ahead and look at your next example. Let me give you the instructions on my smartboard. So, this one is a little bit advanced. I want you to reflect triangle ABC over the line y equals -1/2 x plus 3. So I'm giving you the line of reflection this time, and you are reflecting the pre-image. Try it. Let's talk through this together. Let's brainstorm, okay? So what I've done so far is I have plotted the line, the line that they gave me. Y equals -1/2 x plus 3. If you forgot how to plot a line, you first use your y-intercept. You put a dot at 3 on the y-axis, and then you fall 1, run 2, put a dot, fall 1, run 2, put a dot. So that's graphing that line right there. Now, I'm just going to say out loud everything we know about this line of reflection. First of all, I know, let's say we're going to do B first. We're going to reflect B first. I know B and B prime need to be equidistant from the line of reflection. That's one thing I know. I know that if the segment that connects B to B prime, it needs to be perpendicular to my line of reflection. So I've got this word equidistant and I've got this word perpendicular, and I need to put that into this graph. Let's work with the word perpendicular first. I'm trying to draw the segment that gets me from B to B prime. What will the slope of that segment be? So the slope of our line of reflection is -1/2. Good. So the slope of B prime, kind of the opposite of the other problem we just did. The slope of that segment is 2. It doesn't equal 2, but that's the M. I'll put M. Okay, cool. So here's what we're going to do. We're going to start at point B. We are going to start here. Maybe put an arrow. That's where we're starting. And we are going to travel. We're going on a journey, guys. We're going to travel with a slope of 2 until we get to our LOR, our line of reflection. Ready? Let's travel. Start at B. Pack your bags. Down 2 over 1. Put a dot. Put an actual dot on your paper because we need that in a minute. Down 2 over 1. Down 2 over 1. We reached our destination. It's only a stop. It's not our final destination. Okay. How many slopes of 2 did we travel? 1, 2, 3. Conversely, instead of saying we traveled 2 and we did it 3 times, we could actually say where we traveled. We could actually say I went down 1, 2, 3, 4, 5, 6 and over 1, 2, 3. We could write that down. We went down 6 and over 3, but the other way. So we're going to start from where we left off. And you can either travel with a slope of 2 3 times, or you can go down 6 to the left 3. That's up to you. Down 2 over 1, down 2 over 1, down 2 over 1. No matter how you get there, when you're done, that is B prime. You have now reflected that over the line of reflection. Let's do C next, because it's the easiest one. Where does C prime fall? On the LOR, right? That's pretty confused. Not pretty confused, I just read your typing. That's pretty cool. So when a point lies on the line of reflection, then its image also lies on the line of reflection. Okay, lastly, let's do A. We're going to start at A, and we need to travel with a slope of 2. Down 2 over 1, down 2 over 1. This time it only took me 2 journeys to get there. Here's where I left off. I do it again. Down 2 over 1, down 2 over 1. A prime. There's a lot of dots here. Let's connect the correct dots. I'm connecting C to A prime. Sorry, C prime to A prime. B prime to C prime. B prime to A prime. Oh my goodness, it's beauty. It's so pretty. That is our triangle reflected over the complicated line of y equals negative 1/2 x plus 3. We are transitioning, flipping our paper over. We are ready to rotate. And these rotations are going to start off easier than our reflections. Okay, ready? So we are on this side of our paper right here. Our first goal is to determine the degree of rotation. Not locate the center of rotation, but determine the degree of rotation. You know that almost all of these, we begin by connecting the dots, but you do need to know which dots we're connecting. In this one, when we're looking at a rotation, we're not going to connect the corresponding vertices. We're going to connect the vertices to the center of rotation. So get your ruler. You only need to do one of them. I would recommend C and C prime. Get your ruler and connect the corresponding vertices to the COR, center of rotation. In this example, the center of rotation is the origin, but we know it doesn't have to be the origin. As you can imagine, this is pretty easy. You get your protractor out and you measure the angle. That's all there is to it. You're getting about 50 degrees. It should be about 50 degrees. Yep. So you want to make sure you put your protractor's middle on the center of rotation. And then you can measure. You can't even really see my numbers on there, but I'm getting 60 degrees as well. You can put it the other way, which is probably what you did with your protractor there. All right, let's go ahead and write down the degree of rotation counterclockwise and clockwise. 50, 50, 50, yes. Okay, so you need to pay attention to where your primes are and where your original points are. Okay, yes, you got it. So when we go from our original to our prime, which way is that arrow pointing? Clockwise or counterclockwise? Counter, okay. So our counterclockwise degree of rotation is 50, and it has it at the bottom of your page there. And then, of course, to get our clockwise degree of rotation, we just subtract it from 360. 360 minus 50. So our clockwise, if we were to travel this way to get to C prime, would be a 310 degree rotation. Okay, go ahead and find the clockwise and counterclockwise degree of rotation from FG to F prime, G prime. So when we're doing this all together in class, it's really easy because we're taking it one example at a time, we're going over it each time, but you are going to have to keep track of how did I start a problem like that? How did I start a problem like the first one we did on the back? You're going to want to really look at these notes and let it sink in what each process was for all the different problems. So in this problem, we connected our corresponding vertices to our center of rotation, which was H. Once we connected them, we got out our tools, our protractor, and we measured the angle. I'm getting 110 degrees. Right there, if you can see that. Yep, you can see it. If I'm traveling this way, That is against the hands of the clock. The hands of the clock do not move that way. So that is counterclockwise. So then our clockwise degrees would be, I bet you already typed it. Thank you, Hatham. Subtract from 360 clockwise, yay. Okay, next example. Now we're going to actually rotate. You love this unit. Oh, yay. We're going to actually rotate the figures ourselves. Okay, so I'm going to give you the center of rotation. I want this to be the origin. That's always the default if it doesn't say. This is your center of rotation. I want you to rotate that triangle counterclockwise, because that's the default, with a degree of 60. So rotate it counterclockwise with a degree of 60. The way that we'll do this is we'll take one vertice at a time. One vertice at a time. So let's start with the easiest one, which in my mind is E. What do you think we do first? I need your full focus. Come back. Connect E to our center of rotation. Very good. Do it. So we are on this example right here. Our center of rotation is the origin. We are connecting point E to our center of rotation. Now what? Should get a tool out, right? Can't make 60 degrees just by eyeballing it. Okay, so we're going to place our protractor on, let's call it EO if I'm calling the origin O. Place our protractor on EO and measure a 60-degree angle. See how I'm putting a little tick mark at 60? Measure with the protractor, yep. Putting a tick mark at 60, and then I'm going to connect O to that. But if I had a pencil, which I'm not using a pencil so you can see it, if I had a pencil, I would make that a really light line by Hatham, because that's not your answer yet. That would be a very light line that I could erase later. Now the thing is, E falls on this line, but where do I put E on this line? Good, equidistant, Sharon. So E prime has to be equidistant from O as E is. I highly recommend using a compass for this. It is like, the compass was like created for this. But if you really would rather use a ruler, you can measure the distance from O to E and then measure the same distance from O to E prime. But like I said, this is what compasses were created for. So I'm going to put my needle on O, and I'm going to put my pen on E. And make myself a little arc. And mine's not perfect this time. It was perfect. I did it last time, promise. Your E prime should fall at -3.5. Make sure it's falling at that whole number because I forced it to be a whole number just to make it pretty on us. Okay? I trust that you can do G and you can do F, but we're going to move on so that we can finish our lesson. So you're going to need to follow through with G and F at home. Okay, we saved the best for last. How to determine the center of rotation. Now, if you remember when we did Sketchpad yesterday, it was so much easier. What we did first in Sketchpad was we had Sketchpad, we literally clicked a button and it connected the vertices for us. So it connected, pretend like these are straight, F to F prime for us, G to G prime for us, and H to H prime for us. Then we clicked another button and some light blue lines just appeared on the screen. Those light blue lines were the perpendicular bisectors of those three segments. It got a little bit messy. I'm not even going to pretend to draw them. The perpendicular bisectors of the segments. Then we noticed that those light blue lines all intersected at a single point, and at their point of intersection was the center of rotation. Go ahead, let's do this together. I'll get my hover cam back out. Let's do this together using our tools and see how close we can get. Because if you don't get it perfect, that is okay. I'll show you what it'll look like on your test. So I recommend doing them one at a time. I recommend connecting F to F prime, like that, and then constructing the perpendicular bisector. Open it more than halfway. Put your point on the other end point. And if I had a pencil, I would draw these nice and light, but I'm using kind of heavier pens so that y'all can see it better. I don't know where they're going to intersect, so I'm going to make it nice and long. Okay, the good news is I actually only have to do 2. Which other one do I want to do? I'll do G, G prime. Only required to do 2, although you could be thorough and do 3 if you want. I put my needle on G. Right now I am not opened more than halfway, so I need to adjust my compass. This is where it gets messy. More than halfway. Needle on the other end point. All I have to do is hit that arc. I don't really have to draw as big of arcs as I've been drawing. I have to eyeball, where did those intersect? Okay, here and here. Connect these dots. Might not be perfect, but we're going to get as close as I can. So now we're trying to find out where those orange segments intersected, and I hope that it's at -2, -1. But if I'm off a little bit, that's okay because it'll be multiple choice on your test. What do you think about that? A little messy? Yeah? Okay, yeah. I might have been off. You might not have been off. Now, what it's going to look like on your test is a little bit different. It's going to be multiple choice. So the good news is you still need to know how to locate the center of rotation, but you get to kind of bypass a step. So if I give you, this is the last example of the day, if I give you this one on the test, first you need to find 2 coordinates that go with each other. You can't just connect any 2 dots you feel like. You need to find some corresponding coordinates. I'm going to take this guy. I'm going to look over here. Okay, he got rotated. Oh, he landed here. Okay. So I'm going to find 2 of them. I'm going to connect the dots. I am not going to find another one. I only have to do this 1 time. I'm going to get my compass out. Can't get away from doing this. You still have to construct the perpendicular bisector. More than halfway. Oh, some of these points are already out of the running, I can tell. Ooh, I missed myself a little bit. There we go. And now, there is only one point in this picture that lies on the perpendicular bisector. And the winner is... the Golden Globe goes to... just kidding. I watched this on Sunday night. Hey! Okay. So, yeah, we could have located it by drawing all of the segments and drawing all the perpendicular bisectors, and they would have converged at A. But you know what? Only one of those points lie on the line of rotation, and so we're done, the perpendicular bisector. A is the center of rotation because it lies on the perpendicular bisector of the segment connecting the corresponding vertices. How's that? Okay, guys, this is not a homework to skip. Every one of you are doing your homework tonight.